If 28, I should show it to you, sorry. If 28.9 grams of aluminum chloride reacts with excess silver nitrate, how many grams of precipitate will be produced? This is a double replacement reaction, ladies and gentlemen. You have two reactants that are listed here. You will create two products by changing the metals in the compounds. The one metal, aluminum, will take the place of the silver. The silver will take the place of the aluminum. They will switch what they are with. You then need to see which of the two products will be a precipitate. That, ladies and gentlemen, is on your pink sheet. That is this table up here, where you look at what aluminum is with and what silver is with on the product side, and you determine if it will be a precipitate, meaning a solid that settles out of solution, or if it will remain aqueous, meaning it will stay dissolved in water. So that's where you're at to begin, ladies and gentlemen. After that, your three steps. Take what you're given, get it into moles. Use the molar ratio to go from what you're given to what you're going to. And then report out in your final answer, which will be grams. Just like we've been doing, ladies and gentlemen. We will give you 10 minutes to get this done, then we will go over. If you can't get it done, get as much of it finished as you can. If you have questions when I'm done with attendance, call me over and I will help you. Licio. So again, ladies and gentlemen, if you have questions, feel free to call me over. I will be happy to assist you. Actually, wait, we're going to test. Okay, then we better get it started. And I can keep you a little bit into send you with Wendy, give me 1 second and I will be there, okay? Actually, give me more than 1 second because I'm slow. Oh, you're going to do the quiz today. Because you still have to do the Unit 6 quiz too. So let's do the quiz today, and then we'll do the test like next week, Monday or Tuesday. Okay? Because you should do the quiz first. Okay? I don't know the answer to that question. If you have questions, please stop. All right, let me. Okay, so that aluminum is going to change places with that silver. Meaning silver is going to be with the CL, aluminum is going to be with the MO2. Okay. And then on Monday we'll make a proposal. Yes, yes.
This is for under 10 school.
Correct. Correct. Now you gotta look at them and figure out which one precipitates and which one does not. So you need that pink sheet that we gave you. You're using the side that says solubility of ions reference sheet. Start by writing your balanced chemical equation. Start by writing your two reactants. These, what you are given up there, are the reactants. Those are the things that are before the arrow. Then you have to predict the things that are after the arrow, but you have to write the things that are before the arrow first. Okay, good and good. Yes, and yes. Now you're ready to go. So, now the problem says how much precipitate will be created, which means that's the one you're looking for. When you figure out which one is your precipitate, ladies and gentlemen, which one is your solid, that is the one that you're looking for then. That is the product that will be what you're going to. All right, let's make sure you've got your equation correct here, ladies and gentlemen, okay? We'll go through this, then I'll give you a little more time to do the 3 steps. But we got to make sure you've got your equation right first, because if that's not set up correctly, everything else from there kind of falls apart. All right, Elsa, can you give me the formula for aluminum chloride, please? for aluminum chloride? Okay, do you have silver nitrate then? Okay, give me the formula for silver nitrate. AgNO3. Now, both of these are going to be aqueous at the start because always the reactants in a double replacement are aqueous. All right, Denaya, can you give me aluminum chloride? AlCl3. Perfect, ladies and gentlemen. Those are both aqueous, okay? So now we've got our reactants. We put an arrow down because now we are going to go to the product side. On the product side, ladies and gentlemen, we are going to switch the silver and the aluminum, what they are with. By the way, I do not care what order you write these in on the reactant side. I did silver nitrate first. You could have done aluminum chloride first. It doesn't matter, okay? But these two things need to be before the arrow. All right, so now, ladies and gentlemen, what we're going to do is we're going to write down what the products are. Give me one of the products, please, Katie. AlNO3. Good. As I'm walking around, I'm seeing you guys write these formulas correctly. That is a good thing. You're starting to remember, okay, I got to balance off charges all the time. Aluminum is a +3. Nitrate is a -1. You need to put it in parentheses and put a 3 by it. All right. Jaden, can you give me the other product? AgCl. Good. Again, silver is a +1. Chlorine is a -1. On the other side, we had silver and nitrate together, a +1 and a -1. We had aluminum with chlorine, a +3 and a -1. That's why the 3 here. That's why the 3 here. Okay, next, we need to figure out which one precipitates. Jesus, did you find which one precipitates?
AgCl is solid and Al3 is aqueous.
Okay. Now, double replacement reaction, ladies and gentlemen. 2 compounds creating 2 new compounds. 3 of the 4 will be aqueous. 1 will be a solid. Okay? Now, technically, there are 2 other ways of identifying a double replacement reaction. The one that we will use 99% of the time is finding a precipitate, a solid. And again, if you are unsure where we got that from, ladies and gentlemen, on that pink sheet, the one that says solubility of ions, anything with NO3 is always aqueous. So the silver is aqueous here because it's with NO3. The aluminum is aqueous here because it's with NO3. Anything with NO3 is aqueous. Chlorine is the other one, ladies and gentlemen. Chlorine is almost always aqueous, which is why aluminum and chlorine here is aqueous. But it happens to be with one of the 3 exceptions of things that it will not be aqueous with, that it will be a precipitate. It is with silver. So on the product side, since silver and chlorine are together, it becomes a solid. Questions? Okay. Now we do have one thing left to do before we can move on, and what is that? We need to balance it. Now again, if you need to set up a scoreboard to balance it, absolutely nothing wrong with that. Okay? Absolutely nothing wrong with that. If you can do it without a scoreboard, absolutely nothing wrong there. So I'm going to use the scoreboard because I can easily erase it when I'm done. Silver. By the way, I'm going to keep NO3 together as a group here. You can break it up if you want, but since it's NO3 over here and it's NO3 over here, I'm leaving it together. Aluminum, chlorine. Again, reminder, the reason I do this under the arrow is so that I can keep track left side and right side. 1 silver over here, 1 silver over here. 1 nitrate group over here, 3 nitrate groups over here because of the parentheses. It says there are 3 of those groups. 1 aluminum over here, 1 aluminum over here, 3 chlorines here, 1 chlorine here. So I need to balance 2 things. I need to balance the nitrate and I need to balance the chlorine. Nitrate, I need more nitrate on the reactant side. So I'm going to put a 3 in front of the AgNO3. I know that doesn't help me with the Ag, but it does get the NO3 balance. Now I need to balance off the silver or the chlorine on the product side. So I'm going to put a 3 in front of this compound here, and it will balance both of them at once. Now you have a balanced chemical equation. Now again, if you were to write the formula wrong on one side or the other, you're not going to get this to balance. If you have NO3 here and you don't have NO3 here, it's not going to balance. Charges will not allow it to balance. So you've got to be careful. All right. You've now got a balanced chemical equation. One last thing before we turn you loose on these 3 steps, and maybe some of you are there. Identify what you are given. I am given 28.9 grams of the aluminum chloride. I am looking for so many grams of AgCl. It says how many grams of precipitate will be produced. That is the precipitate. That is what you are looking for. This question or this problem now becomes these 3 steps, ladies and gentlemen. Get what you're given into moles. Use the molar ratio. What you are going to on the top, what you are given, or what you are in on the bottom. And then report out your final answer in the unit they ask you to. You got 5 minutes to get her finished, ladies and gentlemen. If you're already done, you can work on the packet things that we gave you yesterday. If you have questions, now would be the time to ask.
This is not equal. This 3 moles is not equal. Okay? So this step and this step will always be 1 mole over 4. This ratio takes care of that. So make that open and then check your calculation. That 3 goes right here. And this in the ratio ratio step. No. No, okay. So the number that you put out in front there is based on the number that is in front here. And for this one, it's based on the number that is in front there. And that's where, if there is a number in front, this step takes care of it. This is way too high. That is not correct for silver chloride. I think what you did is you took it times 3. Don't do that. Just run the massive, just silver chloride, 1. The 3 gets taken care of the rest. Okay?
Okay, so try something.
You know what? And even you can't reduce it to
Oh,
now it's 2 and 6, 3 and 6.
Silver plus chloride plus.
The only time you would have to adjust it is if you accidentally miss like the lowest, somehow you caught it like on a second.
What?
You know what I mean?
The four major kinds of
So,
states and
If you balance it correctly, it's gonna come out the lowest.
every world. Study up. Listen to your mom's words. Remember that.
And then
Still.
you add that.
okay, I forgot you said.
And then just three times.
Song.
There's three chloride.
I don't know that I understand it.
There's three chlorine.
I don't see it.
Wait. Hold on.
It's found with
So
the
which one?
Acute, yeah. Oh, never mind. I know
Oh.
that.
Okay.
I don't see it.
it's the
So-
long is the Mongolian.
She's finding silver chloride, so the mass of silver plus the mass of chlorine, right? But don't multiply by 3.
So just ignore.
I don't remember.
The 3 gets taken care of in your ratio step, okay? So when we do formula masses, we only do the formula mass for 1 mole of something, okay? So like here you did that, and here you did that, and this is where it takes care of that 3 that's in front of it. Okay. Now, when you're doing the math for the entire problem, then yes, you're gonna multiply that 3 because it's on top, okay? But what I don't want you having to do is trying to figure out how many times to increase a formula mass or decrease it. That all gets taken care of in that one ratio step. Well, you haven't put the top of the ratio step here yet. So what are you going to, in this formula, what are you going to? So then that is where this 3 goes on top of 3 moles
I literally tried to walk it.
of AgCl. Now, I don't mind that you're doing that, but you're gonna get confused because you're gonna have moles here and moles here and moles here and moles here. I would put down what their moles are. So like that is moles of AlCl3. That is moles of AlCl3. Yes. You do, but not in your mass here. So you take this times 3 times this, divided by this number. Okay? But don't do this over 3 or this times 3 and then 3, otherwise you're doing that same step twice. Okay?
All right, ladies and gentlemen, let's go through this. We'll walk through the steps. I will, again, try to point out a couple common mistakes that people sometimes make and are sometimes doing, and we'll try to get this finished up and give you some time to work on some more problems. All right, so again, ladies and gentlemen, we are to the point where we are at our 3 steps here. Take what you're given and get it into moles. Use the molar ratio step, report out in your final answer. So for us to take what we're given and get it into moles, we're going to take that 28.9 grams of AlCl3. Now again, I'm not saying you have to write the AlCl3 here, but it helps to avoid confusion if you do. Okay? I'm going to take this times a conversion factor. We're going to use formula mass. Now, on the top goes 1 mole of AlCl3. That I would put the AlCl3 here so that you could see it cancel out later. Could somebody give me the formula mass for AlCl3, please?
62.4.
No, that is not correct. There are 3 chlorines there. They're 35.453 each. So that's 105 plus 26. So I'm sorry, the last part, Alicio.
133.330.
Like that? Okay. And again, if we're a few tenths off, if we're a few hundredths or a few thousandths off, might be rounding that you did or something like that. If you're using the numbers on the periodic table, we should all come up with the same. But sometimes people round it and that happens. All right, next. That is step 1. Take what you're given and get it into moles. Step 2 is to use a molar ratio. Now, here is the reason we use a molar ratio. The molar ratio accounts for any number that is out in front. So that I don't need to worry about doing 3 times the formula mass here because there's a 3 here. Formula mass is always equal to 1 mole. The ratio step that we are about to do will take care of any numbers that are out in front. It will make it so that we multiply or divide by them, and the ratio step will take care of them. Okay? So, the ratio step is what I am given on the bottom. I am given 1 mole of AlCl3 because with no number in front, that means 1. So I'm going to put 1 mole of AlCl3 on the bottom. Now on the top is what we are going to, which is the 3 moles of AgCl3. That goes on the top. This here comes from right here. This here comes from the fact that there's no number in front right there. The ratio step will take care of that for you. Questions? Take what we've given, got it into moles, use the ratio step. What we are in on the bottom, or what we were given, what we are going to on the top. Now, because we are going to grams, we are going to report out our answer in the unit of grams. To do that, we are going to convert from moles into grams. To do that, ladies and gentlemen, we use formula mass again. So, 1 mole of AgCl on the bottom. Why? Because I only want to find the formula mass of 1 mole of it. I'm not worried about the fact that there's a 3 in front. I've already taken care of that with the ratio step. So I can just worry about what is the mass of 1 mole of AgCl. Can somebody give me that, please? I think that's the one you were giving me earlier, Denaya. What it? 143.32. Thank you. All right, let's look at this. Okay? Grams and grams cancel out. Moles and moles cancel out. Moles of AlCl3. Moles of AgCl cancel out. The only thing that I am left with right now, ladies and gentlemen, is grams. That's what I want. So, mathematically, 28.9 times 3 times 143.32 divided by, since there's only 1 number on the bottom, the other 2 are 1s, I can just put 133.333 in my calculator. Don't need parentheses around it. Don't need anything else. Hit enter. Tell me what we get. So 93.19 gives us 93.2 grams of AgCl. I don't need the AgCl in my unit, but I do need the grams. Okay? So if I was grading this, ladies and gentlemen, 1, 2, 3, 4. 1 point for states, 1 point for balancing. That's 6 points. 7, 8, 9, 10, 11, 12, 13. That's how I would grade it. Questions? All right. So you have 20 minutes, ladies and gentlemen. The problems in your packet are still there for you. There are 3 problems sitting on the back lab stations and a couple copies up here, and I will put it up on the board. 3 other problems that are just like what you are doing on the ones in your packet. If you finish some of the ones in your packet and you want a different problem to try, they are right here for you, ladies and gentlemen. In 20 minutes, though, we are going to introduce you to what we do if we are given gases. Okay? So, go to work. If you have questions, I will be happy to answer them. And I will put the questions up on the board here right now. You certainly may. Those just hit the ground.
That's lovely.
Well, that's what happens when you put them there. There are the 3 problems that I gave you in the back if you want them here. The answers are on the back, in the back. The answers are on the next slide in your daily agenda. Hang on, Madison, I got them out. I'll grab them out. I didn't know you smelled. Where are they? All of them, okay. Sorry. There you go. No problem. Thank you. Your quiz tomorrow is only on the molarity part from Monday and Tuesday. These problems are not in your quiz tomorrow. No, we did that as those ones in the back and in the daily agenda from Monday and Tuesday. That was those 6 problems that we did on molarity.
These ones?
Yes, those would be the ones.
We're doing it all of the different, 3.
Well, think about this. There are 6 problems, right? How many things are there to solve for in that formula? 1 on each. I'm sorry. Did I say there were 6 problems on the quiz?
Yeah.
3.
Oh.
3. My bad. 3 problems on the quiz. We did 6 practice problems.
Yeah.
There'll be 3 on the quiz. You do that and look like. Well, if you want to rewrite it down. That's up to you.
600, and mine should be another 21. So, yeah. 84 units. Get that. There's a 3 after this year, was supposed to be a 2. Because the CO2.
No. You need the 3 in front of the CO and the 3 in front of the CO2 to balance off, because remember, there's oxygen also in the FE.
Oh.
So there's 3 oxygens there, then there's 3 in the CO2, that's 6 on one side. The 3 in front of the CO2 on the other means there's 6 on this side then, okay? So that's the balancing thing. Okay? What? That is a single replacement reaction. Oh, no, it's none. It's none, because you've got 2 compounds creating a compound and another. So it's none of the types that I've given you.
Is this right?
So which one are we doing, just so that I know? I know, but I need to see the
Oh, no,
equations
okay,
so that I can. Okay, so. Alright, so you know, 1, 2, yes. 2, 2, yes. Our math is, okay. You're fine, you're close enough, but because you did 58 instead of 58.44, that's how we ended up a little bit different, but not enough to where I would be upset.
That's showed up on the calculator. That's
Well, but what did you use for NA? Okay, so put that into your calculator. Now add to it chlorine. Somehow you got into a fixed mode where it is only showing you where it's not showing you decimal. It's deciding to stop at the ones place.
I was wondering when we were doing the equation, it was like.
Oh, here we go. So back to- That means now, if you do 22.99 plus 35.45, 40, now you'll more decimal places. Yeah, just, the good news is, everything you did in your process, perfect.
Okay.
Yes. Okay, so, you're not doing one simple step I asked you to. How many grams of, you're right, how many grams of CO? So what are you looking for? Yeah. Then put question mark, grams underneath it. Or on top of it, I don't care. Okay. So, she produced 209.7 grams of FE. So, what do you put over there by the FE? Well, how much are you getting? Read the problem. Okay, so now you're gonna take this and do what to it? Why would you put FP2? Deny. That's not part of the formula. You don't put that to it. You only write down what the formula is. What does that do? Put it into moles, your base substance. Okay?
We are now watching a video on okay. Yeah, I built a cabin. It's not it's true. Okay. Gotcha. Yeah. And then we also have
Roles of duty. I understand that.
Yes.
this is happens with
Okay, where did you get the 81.43? Okay, so that's 22.990, right? And that's 35. So 23 and 35 is about 58. So we don't have yet. Don't do the 2. Because that 2 is part of this. It is not part of that formula. That formula is just NaCl. That's what you use for that up there. And you use 1 down here. Okay? So by doing the 2 here and the 2 here, they will cancel each other out and you don't want to do that. Okay? I want to keep this as simple for you as I can, so just find the formula mass of that, because to be honest, even if you did do this, that's still not the right mass, because you doubled, I think, just the Na and F with Cl. So just do formula mass based on the formula. Ignore the numbers in front. The only place that the numbers in front come into play is in this step right here. Okay? Wait a minute, break. Come on. What do you want? Is this what you're going to? Is there a 3? That's this what you're in. And there's a 2 in front of it, right? That's what. The thing of cobalt. That's not cobalt. That's a capital O.
Bro, in the way.
Bro is away. I got 2 capital letters mean 2 elements being a compound. Really? So when you're looking here, that looks like a small O to you, and that looks like a small O to you. No, it's not carbonate. Don't even turn that over. This is carbon dioxide. This is carbon monoxide. About 5 minutes, then we're gonna move on, ladies and gentlemen. So if you got questions, now would be the time to ask them. How we doing?
You know. Where you from?
Yes, Senator. What do you need? What are you trying to do? What is the last step?
I can't see that. Something on my hand.
Okay, what are you trying to get into? Okay, so do you know what, how do we go from moles of steel into grams of steel?
Okay, so how do you
Okay. How many moles on the bottom?
for this test?
I don't care how many there are. One mole on the bottom.
So am I doing like a full graph? Yeah, so am I looking for this? And then, am I adding the change size as well? It says calculated plus 2, so I just have to 2.
All right, ladies, gentlemen, children of all ages, come on back to your desks real quick. Open up your computers and get to the EISN in the Canvas classroom. Now, as you are, well, go ahead and do that first. Again, the answer keys are on the next page for you, ladies and gentlemen. They are here for you to look at, here for you to see, here for you to use. The biggest thing that I'm seeing with people right now, ladies and gentlemen, is you are getting confused by these numbers that are out in front to balance the equation. When you are doing a formula mass, we always do the formula without worrying about anything in front of it. That is the formula for KClO3. That is what you will use to find formula mass, and it will be equal to 1 mole. 1 mole. These numbers out in front, ladies and gentlemen, always are involved in the ratio step, and that takes care of the fact that there are 2 of these to 2 of these to 3 of these. You do not have to worry about it when you are calculating a formula mass. All you look at is the formula. The mass of 1 potassium plus 1 chlorine plus 3 oxygens. Find that mass, 122.548. always equal to 1 mole. Okay? So whenever you're doing mass, it's always 1 mole on the top or 1 mole on the bottom. Any numbers that are in front get taken care of in the ratio step. 1 mole over 55.85, 28.01 over 1 mole. 1 mole over 22.99, 58.44 over 1 mole. Do not worry about the numbers in the equation. They are there and they get taken care of in your ratio steps. Questions? Okay? Good. Now we're going to take a look at what happens if they give us information and they give us information and that information is for a gas. So here's what that will look like, ladies and gentlemen. In the formation of acid rain, sulfur dioxide reacts with oxygen and water in the air to form sulfuric acid. Write a balanced equation for this reaction. If 285 milliliters of sulfur dioxide gas at 98.5 kpm at 18.7 degrees Celsius reacts with excess water and or oxygen and water, how many grams of sulfuric acid will be produced? In the end, what are we asking about the sulfuric acid? We're asking to find its what? So what are we going to use in the end? Formula mass. Anytime you are given a mass or asked to find the mass, you will use formula mass. Okay? So, a lot of stuff here to unpack. First of all, sulfur dioxide. Sulfur dioxide is a covalent compound, ladies and gentlemen. I know that because it is using prefixes, di. So we do not do anything with charges with sulfur dioxide. We write it entirely based on the name. Now, since there is no prefix at the start in front of the sulfur, how many sulfurs does that mean? 1. 1 sulfur, 2 oxygens. And that is a gas. Plus, it reacts with oxygen. How do I write oxygen? O2. Also a gas. And water. How do I write water? Good. H2O. Now we could call it a liquid. If you called it a gas, I would not be upset. Okay? Reacts in air to form sulfuric acid. Sulfuric acid does not begin with hydro. Since it does not begin with hydro, is it a binary or a ternary acid? Ternary. Ternary acids are named based on the polyatomic that gives us an ic ending. What polyatomic gives us an ic ending? Okay, which is sulfate SO4. What is the charge of sulfate? -2. I'm going to put that with hydrogen because it is an acid. So when I do that, ladies and gentlemen, what does my formula become? And we know that acids are aqueous. There is your formula. Now, the next thing we have to do is what? Balance it. Now, I'm not going to kid you. Balancing this one, you're going to probably have to use a little trick we did before. But let's see. H, S, and O. 2 hydrogens over here. 2 hydrogens over here. 1 sulfur over here. 1 sulfur over here. 2, 4, 5 oxygens over here. 4 oxygens over here. Okay? My oxygens are not balanced. Now, there are multiple ways of doing this. I am going to use the 1/2 trick. I am actually going to put 0.5 in front of the oxygen here, because then that goes from 2 down to how many? 1. 1 oxygen here, 2 here, and 1 here. Now give me 4. It is balanced. Can I leave it this way? How do I get rid of a 1/2 in a balanced chemical equation? Multiply everything by 2. Everything. So, ladies and gentlemen, this becomes 2. This becomes a 1, because 1/2 times 2 is 1. Ugh. Didn't want to do that. All right. Okay. There becomes a 2 here. And there becomes a 2 here. That is now balanced. Are we all okay with that? Okay. So now, ladies and gentlemen, we are going to identify what we are given and what we are looking for. We were given 285 milliliters of sulfur dioxide gas. So here we are given 285 milliliters. And this gas is at 98.5 kPa and at 18.7 degrees Celsius. What is all of that setting up for us to use? PV equals nRT. PV equals nRT. Now, what are we asked to find? How many grams of this? So this problem is going to end like our last one. It's just not starting out that way. So we are going to use PV equals nRT to solve for what? Which is in? So guess what? Take what you're given, get it into moles. We are given a pressure, a temperature, and a volume of a gas. Get that into moles. So we are going to use PV equals nRT. Okay, so pressure, 98.5 kPa. Volume, what do I need to do to this volume? I need to put it into liters. Because remember, volume in PV equals nRT has to be in liters. N for what I'm solving for, what do I use for an R value? 8.31. Very good, because it's in kPa times liters over mole times Kelvin. Now, what do I need to do to that 18.7? Add 273 to it to make 291.7 Kelvin. Now, I need to get what alone? So I'm going to take this side and I'm going to divide it by 8.31 kPa times liters over mole times Kelvin times 291.7 Kelvin. All of that will cancel out. What I do to one side, got to do to the other. Okay. This cancels, this cancels, this cancels, this cancels. Unit-wise, kPa and kPa cancel. Liters and liters cancel. Kelvin and Kelvin cancel. What's the only unit I'm left with? Moles. So someone please tell me what N equals. How many moles when you do this math of 98.5 times 0.285? What are you going to do to those two numbers on the bottom? Put them in parentheses. One set of parentheses. Somebody tell me what we get for N.
0.01158.
We get that small a number?
Yeah.
Yes! Absolutely nothing wrong with that. Remember, 1 mole is how many liters at STP? We're at 285 milliliters. You're going to get a very small number. And since I was making such a big point of it, I didn't pay attention to what your number was, Jesus. So can you please give it to me again? 0.01158.
0.1158.
Now, the other thing I like about what Jose just did is he gave it to me in 4 sig figs, because in the end, I'm going to need how many? 3. Carrying more sig figs than I need. Now, what have we done? 3 steps. What have we done? Took what we're given and got it into moles. What's our next step? Now, I will tell you this. You have been seeing me set this up. Times this, right? PV equals nRT does not lend itself to doing that. You've got to do this calculation and get this number. But now that I have this number, I'm going to fit it into here. I'm going to put it into here. So I'm going to put 0.01158 moles of SO2. Got it into moles. What's my next step? Use the molar ratio. Molar ratio step says the moles of what I'm in go where? In or given? Bottom. So what do I put down here? 2 moles of SO2. That 2 here comes down here. Okay? What goes on top? Two moles of H2SO4. And again, this 2 comes from right here. Any questions? Take what you're given, get it into moles. Molar ratio. Third and final step. Well, what's the step though? Report out in your final unit. What is your final unit? So, to go to grams, I need formula mass. Formula mass of what? Okay, so 1 mole of H2SO4 on the bottom. Someone tell me what the formula mass of H2SO4 is. Should be around 98 point something. 0.0 what? I'm sorry, I'm missing that. Thank you. Sorry. I just couldn't make out what you were saying. My bad. Okay. So, moles of SO2 cancel. Moles of H2SO4 cancel. I am left with grams of H2SO4. Now I just need a number. Somebody, please. 1.1 what? 4. Well, can you give me the next number though? I just want to make sure you're rounding correctly. 1.45?
Yeah, so originally it was 1.35.
Okay, thank you. 1.35, which we would round to 1.14. Thank you. Questions? The only difference between this and our last problem is how we take what we're given and get it into moles. Once it's into moles, this becomes just like our last problem. Take the moles times the molar ratio. Report out in your final unit. Okay? Questions? Okay. We are not going to get it done, but I want to take a look at the next problem, please. One in a series of reactions that inflates airbags in automobiles is the decomposition of sodium azide. Now, why do I give you the formula for sodium azide? Because there's no way for you to find it. Look on the periodic table. Tell me if you find azide. It's not on there. That is the name of this compound that should be sodium nitrite. Okay? But this is a unique, different kind of compound because look at its formula. NaN3. Okay? That is not the way we would write it ever on the periodic table. So I have to give it to you. Okay? This is an exceptional compound. It's not normally the way it would be. If anything, it should be Na3N. That is not the way this is, though. Determine the volume in liters of nitrogen produced, meaning nitrogen is a product. If 100 grams of NaN3 is decomposed, decomposed means there is only one reactant, one thing before the arrow that is going to break down. Okay? At a pressure of 745 millimeters of mercury and a temperature of 24.7, solid sodium is the other product. Okay? So, again, a lot to unpack here. We are going to begin our equation with NaN3, sodium azide. The products are going to be nitrogen gas. How would we write nitrogen gas? N2, how would we write solid sodium? What? Na. So here is your balanced equation, ladies and gentlemen. Okay? Again, I gave you this formula because you would have no way of knowing it or naming it based on anything that I have taught you. So I have to give it to you. But you should be able to know how to do nitrogen gas, and you should be able to know how to do sodium. Right? Okay. Now, the 100 grams of NaN3 is here. So, how are we going to take what we're given and get it into moles? How am I going to turn 100 grams into PV equals nRT? I'm going to use formula math. Now, the PV equals nRT is going to come in when it says nitrogen gas is produced under these conditions. So now I'm trying to find liters of nitrogen gas. What volume in liters? At 745 millimeters of mercury and 24.2 degrees Celsius. The last problem began with PV equals nRT. Now you're going to end this problem with PV equals nRT. And that's what we will work on tomorrow in class, ladies and gentlemen.